do the reaction energy diagram. And I think the reaction energy diagram, for me, it's important. And so what the reaction energy diagram does is it takes the reaction that you're given and it creates a little diagram, and it uses the value for delta H reaction that we solved for. And so let me get a piece of paper, use the back of this piece of paper, and do that. So a reaction energy diagram is a little plot, and on the y-axis we have potential energy, and on the x-axis we have reaction progress. And all reaction progress means is that on the left are going to be reactants, and on the right there are going to be products. So as you move from left to right, the reaction goes from reactants to products. So now this is an exothermic reaction. So this is for an exothermic reaction, and for an exothermic reaction, you're going to have the reactants up here. And so my reactants are 2H2S plus 3O2. And down here are the products. And the difference in energy here between the products and the reactants is what's called delta H reaction. And that's equal to minus 1036 kilojoules per mole. And so, and this is the answer I'm looking for, by the way. This is the picture. And for an exothermic reaction, products are lower. And what that means is that if you look at the potential energy of the reactants, reactants have a higher potential energy than products. For an exothermic reaction. Okay, so that's the sort of the one layer of understanding for that. Now the next layer of understanding would say, okay, if I drew a similar picture with up here and down here, and I had a ball that was up here, and I allowed that ball to drop down, I can say two things about that process. So ball drops. I can say two things about that process. The first is that at the top, it has higher potential energy, and at the bottom, it has lower potential energy, just like I'm showing on this plot. So, and then the other thing I can say is, if I put this ball here and allow it to drop, it would drop all by itself. Because balls tend to drop when going from higher potential energy to lower potential energy. And so that's what I'm going to write down here next is because balls will drop when going from higher positions or higher potential energy when going from higher positions or higher potential energy to lower positions or lower potential energy. And the analogy I'm trying to draw here is that, so just like a ball drops as it goes from higher potential energy to lower potential energy, is that a reaction, if it goes to lower potential energy, will tend to happen as well. So our conclusion, and I realize that we're still trying to figure this out, but a conclusion that I'm trying to get to with this picture is that exothermic reactions that go from higher to lower potential energy PE for potential energy tend to occur all by themselves. Because one of the things we want to understand is, why do reactions happen? And in general, they happen, so in general, exothermic reactions tend to occur, and they tend to occur all by themselves because they're lowering the potential energy as they occur. And a lowering of the potential energy occurs for exothermic reactions because this number is negative, meaning that the products must have a lower number, subtract off the reactants, and you get a negative. So I don't know if you have any questions about that, but please ask if you do.
Yes, Professor.
Go ahead, Mohammed.
Yeah. For the homework, do we have to explain it, or we just have to do the working and draw the diagram?
You just have to draw the diagram. So let's see.
Okay.
So I'm giving you a little bit of background here, and I think I gave this in the lecture outlines too, but all it says is, please also clearly label your reaction energy diagram. So yes, that's all you need to do, Mohammed.
Okay. All right. Thank you.
Sure. Any other questions? Okay. All right. So, Mary, thank you. It says, if the change in enthalpy was positive, then it'd be an endothermic reaction, and the products are higher potential energy, and the reactants are lower. So that is a very good question. So what I'd like to do is, now I would like to draw a reaction energy diagram for an endothermic reaction. And what's interesting is that, remember, if you take a reaction and you flip the reactants and products, then delta H reaction changes sign. So remember, flip reaction, delta H reaction changes sign. So the reaction energy diagram for an endothermic reaction that I will do is going to be the flip of the reaction we just did. So it's going to be 2H2O gas plus 2SO2 gas goes to 2H2S gas plus 3O2. Question, Ankiru?
No.
Okay. And for delta H reaction, if you flip the reaction, then delta H changes sign. So instead of minus 1036, it will now be plus 1036. kilojoules per mole. And we still label our diagram with the same things. And now our two H2Os plus two SO2s are now reactants. And our two H2S and our three O2s are now products. Our potential energy of our products is higher. And so when we do the delta H reaction, our products are now at a higher potential energy. And what we would say about this process is, so first off, this is endothermic because delta H is positive. Second off, if I had a ball that was down here and I wanted to put it up on a shelf, this does not happen by itself. And if I want this to happen, I have to put energy in. And that's exactly what happens. And so I could use my hand to lift the ball up to the top, which would be putting energy into it. And specifically, it would be putting potential energy into it because I would be raising its height. But this does not happen or does not tend to happen by itself. And therefore, this reaction, so endothermic reactions, do not tend to occur by themselves. So in our head, for this course, we just say endothermic reactions basically don't occur or tend not to occur. And if you're going to take Chem 1020, it is a little bit more complicated, but for Chem 1010, it is not more complicated. Endothermic reactions don't usually occur. Exothermic reactions do usually occur. That's what we need to know. So I don't know, Mary, if that answers your question or not. But good. Cool. And what else? I think that's all I wanted to say. Great. And so that means there will be